This is a Camtasia recording the answers for the IV Math PowerPoint. There are many ways to skin a cat, y'all, and there are many ways to solve these problems, and there are easier ways to solve these problems sometimes. But what we're talking about now is using formulas and using ratio and proportion. And if there's other ways that you choose to do that and you come up with the right answer, I'm proud of you. You can do that. When you get out and you start practicing, you'll have your own ways that you do things. But this is our way that we teach it, and if that's not working for you, please get with me and let's look and see what else we can do for you. But for right now, we are using this IV formulas of the total volume to be infused in milliliters over the amount of time in minutes times your drop factor gives you your drops per minute, and that's if you have to infuse it by gravity. If you're infusing it on a pump, typically you run it in mils per hours, so you'll say your total volume in milliliters over the total time in hours gives you your mils per hours. If you leave your total time in minutes here on this formula, you'll give you mils per minute, and you can just multiply it by 60, but either way, it comes out to the same thing. You can use a formula that we've used before. It's called the desired dose over the available dose times the quantity of the available dose, and I'll show you how to use that to get your quantity of your desired dose. How much volume is your desired dose going to be in? Your book calls it the desired dose over the dose on hand times the quantity of the dose on hand. Gives you your quantity of your desired dose. So look at those in the book. If that's not clear to you exactly what all that's about, please look in the book and follow up on that. We talked about 500 mils of dextran to go in over 24 hours. If you have a given mils per hour, you just put your 500 mils over your 24 hours, and it gives you 20.8 mils per hour. Some pumps will let you do tenths, some will not, so it just depends on what type of pump you have. For testing purposes, we'll tell you how we want you to round. If you use ratio and proportion, you can say 500 mils going in 24 hours is the same thing as X mils going in 1 hour. So you solve for X there, multiplying your extremes and then your means, and solve for X to come out with 20.8 mils, and that would be how many mils you would give per hour. Acyclovir, 400 milligrams every 8 hours. Say acyclovir is in 100 mils of normal saline and to be infused over 1 hour. How many mils per hour? The 400 milligrams is fluff. The 8 hours is fluff. All you need to know is there's 100 mils to go in over 1 hour, which gives you 100 mils an hour. Patients to receive Tagamet, 40 milligrams and 300 mils of normal saline every 12 hours. The Tagamet's to be given over 30 minutes. There's a drip factor of 10 drops per mil, so how many drops per minute would you give? The Tagamet 40 milligrams is fluff. You don't need to know that 40 milligrams. You just need to know that 300 milliliters. You don't need to know that 12 hours. All we want to know is for right now, how many drops per minute do we need to hang this dose for? So you know you need to put it in over 30 minutes, so you say 300 milliliters to go in over 30 minutes times your drop factor, which is 10 drops per mil, gives you 100 drops per minute. So what you do is you just have to count in 15 seconds 25 drops, and I'll show you how to do that in lab, and you'll be tested on that when you get into 105 course. The MD orders potassium, 40 milliequivalents and 250 mils of normal saline. The facility's policy states to infuse potassium at 20 milliequivalents an hour. So how many milliliters per hour would the IV pump be programmed for? Well, despite the fact the doctor ordered 40 milliequivalents, the policy says we can only give 20 milliequivalents per hour. So really 20 milliequivalents is our desired dose at this point if we need to figure out how much we can give per hour. So that's the formula here. 20 milliequivalents is our desired dose because we want to give 20 milliequivalents an hour. And 40 milliequivalents is our dose on hand, and 250 mils is the quantity that dose is in, so that gives us 125 mils that we need to give that 20 milliequivalents an hour. We need to give 125 mils an hour to give that 20 milliequivalents in an hour. Or we could say, ratio and proportion, 40 milliequivalents is to 250 as 20 milliequivalents is to X. Solve for X to find out that 20 milliequivalents is 125 mils. So we would give 20 milliequivalents an hour, we give 125 mils an hour. And it would only be for 2 hours because there's only 250 mil back. But that's beside the point to this question. The question just wants to know how many mils per hour. So to give 20 mil equivalents, we give 125 mils in that hour, 125 mils per hour. Patient has the patient has an order for 1,000 mils of D5W to be infused over an hour. The drip factor is 10. How many drops per minute? How many mils per hour? So you say 1,000 milliliters is your volume to be infused. 60 minutes is your time to infuse it. Times your drop factor is 167 drops per minute. It actually comes out to 166.66, but you can't give that. You have to round it to 167. So that's what you come up with. If you wanted to do your mils per hour, you just say 1,000 mils over 1 hour is 1,000 mils per hour. MD orders magnesium sulfate, 2 grams and 100 mils of D5W. The pharmacy recommends that the magnesium be infused at a rate of 1 gram per hour with an IV pump. How many mils per hour should your IV pump be programmed for? So what we need to know is how many mils is 1 gram, because that's as much as we can give per hour. So 1 gram is our desired dose. 2 grams is our available dose. 100 mils is the volume that our available dose is in. So when you do that math, it comes out to 50 mils an hour. Once again, you could do ratio and proportion. If 2 grams is in 100 mils, then 1 gram is in X mils. Solve for your X, and X comes out to 1 gram is equal to 50 mils. We can only give 1 gram an hour, so we give 50 mils an hour. Patient has ordered 25% albumin, 50 mils, over 30 minutes. The tubing drop factor is 20. How many drops per minute? How many mils per hour? 50 mils to be infused over 30 minutes. You need to infuse it. Times your drop factor, which is 20, gives you 33 drops a minute when you do the math. 50 mils over 30 minutes, which is the same thing as 50 mils over half an hour, gives you 100 mils an hour. Those are your formulas. 50 mils is to 30 minutes as X mils is to 60 minutes. You solve for X and it comes out to 100 mils is what you would need to hang per hour to put in 50 mils in 30 minutes. So your answers here are 33 drops a minute, 100 mils an hour, and then 100 mils an hour with a ratio and proportion too. The postpartum patient is to receive 1,500 milliliters of fluid over the next 6 hours. The drop factor is 15 drops. How many drops per minute? How many mils per hour? To get your drop factor, to use your drop factor, you say 1,500 mils over 360 minutes. That's 6 hours is 360 minutes. So you say 1,500 mils over 360 minutes times your drop factor, which is 15, gives you 62.5 drops per minute. And you could not give that, so you would round that to 63. Or you could say 1,500 mils over 6 hours comes up to 250 mils an hour. That's your mils per hour formula. So your answer is 62.5 drops per minute based on your drops per minute formula, and 250 mils an hour based on your mils per hour formula. To do ratio and proportion, you'd have to say, well, if I'm giving 1,500 mils in 6 hours, that means I'm giving X mils per hour in 1 hour. So you solve for X, and that comes out to 250 mils is what you're giving per hour. So it's 250 mils an hour. That's just another way to solve it. The preoperative patient is to receive ANSEF 1 gram IV piggyback over 30 minutes. ANSEF is mixed in 100 mils of normal saline. The drip factor is 60. Once again, how many drops per minute and how many mils per hour? Your formula for your drop factor is 100 mils to be infused over 30 minutes times your 60 drops per mil drop factor. It gives you 200 drops a minute, so you'd have to look at it and regulate your tube until it was dripping 50 drops in 15 seconds. Or you could use, for your mils per hour, you could say 100 mils over half an hour is 200 mils an hour. For your ratio and proportion, you would just say 100 mils in 30 minutes is the same thing as X mils in 60 minutes. Solve for X, and that comes out to 200 mils is what you're going to be given in an hour. If you're given 100 mils in 30 minutes, you'll set the pump for 200 mils per hour. Understand that the pumps have to be set in mils per hour. Even if you're only giving medication for half an hour, you still have to set the rate on the pump in mils per hour. You just take it down after half an hour. So that confuses people. Mr. Sleepy has hypotension and has an order to receive 1,000 mils of normal saline over the next 2 hours. The drop factor is 10 drops per mil. How many drops per minute should be given and how many mils per hour? There's 1,000 mils in 120 minutes times your drop factor, which is 10, gives you 83.3 drops per minute, which of course rounds to 83. So that's your drops per minute. And 1,000 mils in 2 hours means you're going to give him 500 mils an hour if you're giving him 1,000 mils in 2 hours. For your ratio and proportion, you say 1,000 mils in 2 hours is going to be X mils in 1 hour. Solve that for X, comes out to 500 mils, and that's how much you'll give him in 1 hour. Once again, setting the pumps in mils per hour. Mr. Drowsy can't breathe well. He's got a low respiratory rate, and he is got an order received for Narcan, 0.4 milligrams per hour. Given a bag with a concentration of 8 milligrams and 150 mils, how many mils an hour should the pump be programmed for? Your desired dose is, what you want to know is how many mils is 0.4 milligrams, because that's what I've got to give per hour. So you say desired dose is 0.4 milligrams over 8 milligrams, which is what I've got on hand, that's my available dose, times 150 mils, which is the volume that my available dose is in, and it comes out to 7.5 mils I would need to give him 0.4 milligrams. So I would give him 7.5 mils per hour. Ratio and proportion, you would say 8 milligrams is to 150 mils, as 0.4 milligrams is to X mils. Solving for X, it turns out that 0.4 milligrams is in 7.5 mils of medication, so I would give him 7.5 mils of that drip every hour. So it's saying how many mils per hour, because we have to program down the pump, so I would program it at 7.5 mils per hour. If it were a pump that didn't do a tenth, a decimal, then I'd have to just program for 8 mils per hour. But once again, for testing purposes, we'll tell you what we want you to do with regard to that. NPO patient is to receive 1,000 mils of lactated ringers with 30 milliequivalents of potassium over the next 8 hours. The drop factor is 15. How many drops per minute? How many mils per hour? You have 1,000 milliliters to give over 480 minutes times your drop factor, which is 15 drops per mil. That gives you 31.25 drops per minute, given your drop factor formula. That rounds to 31 drops per minute. Using your mils over hours, there's 1,000 mils to be given in 8 hours, so that's 125 mils an hour. Using your ratio and proportion, you'd say 1,000 mils in 8 hours is the same thing as X mils in 1 hour. So solving for X, you would say, well, 125 mils is what you would give this patient in 1 hour if you're given 1,000 mils in 8 hours. So 125 mils an hour is what would be your rate on your pump. Patient has nausea. He's got Phenergan, 50 milligrams ordered, and 100 mils of normal saline to run over 15 minutes. Drop factor of 15 drops per mil. How many drops per minute would you administer, and how many mils per hour? 100 mils is your volume to be infused. Your 15 minutes is your time that you're infusing it over, times 15 drops per mil is 100 drops per minute is what you would give him if you were running it by gravity. To solve it with the mils over hours, you would say 100 mils is to be given in 0.25 hours. That's a quarter of an hour. And what you'd have to do is take your quarter of an hour, or put your 15 over 60 basically, and turn it into a decimal, which is 0.25 hours. And that runs at 400 mils per hour to give him this dose. Using ratio and proportion, you'd say 100 mils in 15 minutes means X mils in 60 minutes, and it would come up to 400 mils that you would need to run per hour to get this dose in 15 minutes. Once again, the pump has to be set in 400 mils an hour. You're not going to give this patient 400 mils. You're only going to run it for 15 minutes, but you still have to set the pump at 400 mils per hour to get it in at the appropriate rate. You just turn the pump off after 15 minutes. Gentamicin, 750 milligrams and 250 mils of ringer lactate to go over 2 hours. The drop factor is 20. How many drops per minute do you administer? How many mils per hour? Your what is getting infused is 250 mils. Your time is 120 minutes. Your drop factor is 20 drops per mil. So that would be 41.6 drops per minute, which would round to 42. Your mils per hour is 250 mils over 2 hours, which is 125 mils per hour. Ratio and proportion, 250 mils in 2 hours is the same thing as X mil in 1 hour. Solve for X, which means it would be 125 mils an hour in 1 hour to give the appropriate amount. And so the ratio and proportion and the formula for that come out the same. All right. Hespan, which is a volume expander, 1,000 milliliters is ordered to infuse over 3 hours with a drop factor of 20 drops per mil. How many drops per minute do you administer and how many mils per hour? 1,000 mils over 180 minutes times your 20 drops per mil drop factor comes out to 111.1 drops per minute, which obviously 111 drops per minute is what it would be. Or if you say 1,000 mils over 3 hours, that's 333.3 mils an hour to give. To figure it out by ratio and proportion, you'd say, well, if I'm giving 1,000 mils over 3 hours, then it's the same thing as giving X mils in 1 hour. So you solve for X, and it comes out to X is 333.3 mils per hour that you're giving if you're given 1,000 in 3 hours. So that's what you'd set your pump for. MD orders Flagyl, 500 milligrams mixed in 50 mils of normal saline to infuse over 20 minutes, drop factor of 10. So I would have to change that 20 minutes to hours. So I would have to put my 20 over 60, and that comes out to 0.3333333, lots of threes. So I could stick that into my formula if I wanted to use that for hours. So for my drop factor formula, I would say 50 mils over 20 minutes times my drop factor, which is 10 drops per minute, gives you 25 drops a minute. And my 50 mils over my 0.33 hours is 150 mils an hour. It might be easier to leave that at 20 minutes and get mils per minute, multiply it by 60, but it gives you the same thing. Ratio and proportion, you'd say 50 mils is to this 0.3333 hours is the same thing as X mils to 1 hour, because you're, once again, programming your pump in mils per hour. You can't program it in mils per 20 minutes. You have to program it in mils per hour. So 50 mils is to 0.333 hours as X mils is to 1 hour. Solve for your X, and that comes out to 150. So 150 mils is what, per hour is what you would program your pump at. You would only run it for 20 minutes, but you would still have to program it like you were going to run 150 mils in an hour. The order is written for penicillin, 5 million units, and 150 mils of D5W every 24 hours. You're using micro drip infusion set. So if you remember from some slides, a few slides back, we said that a micro drip is 60 drops per mil. It's the only one that's 60 drops per mil. The penicillin is to infuse it in 45 minutes. How many drops per minute? How many mils per hour? So you would say 150 mils over 45 minutes times your drop factor, which is 60, gives you 200 drops per minute. So you would run it at 50 drops every 15 seconds. In your mils per hour, you would say 150 mils over your 45 minutes, which is 0.75 of an hour. It's 3/4 of an hour. So to turn that to a decimal point, you'd say 0.75 of an hour. Divide that out, and it comes out to 200 mils an hour is what you would hang on your pump. Using your ratio and proportion, you could say, well, if I'm giving 150 meals in 45 minutes, that's the same thing as giving X meals in 60 minutes. Because, once again, you got to program that pump like you're giving something in 60 minutes. So 150 meals to 45 minutes is X meals to 60 minutes. Solve for X. X comes out to 200. So you will program the pump for 200 meals an hour. You're not going to run it for a whole hour. You're going to run it for 45 minutes because you're only given 150 meals. But to set it in meals per hour, you have to program it at 200 meals per hour to get the appropriate rate. The patient is to receive 2,500 meals of total parental nutrition, TPN, between the hours of 7 p.m., which is 1900, and 7 a.m., which is 0700. The drop factor is 10 drops per meal. How many meals per hour will you program the pump to infuse? The drop factor is fluff here. So you will have 2,500 meals to be given over 12 hours, which is 208.3 meals an hour. The patient has an order for 1,000 milliliters of Ringer lactate to be infused over 1 hour. The drop factor is 10 drops per meal. How many drops per minute will you administer? How many meals per hour? With our drop factor formula, you say there's my 1,000 meals is what I want to infuse. My hour is 60 minutes that I want to infuse it in over, times 10 drops per meal is 166.6 drops per minute, so that's 167 drops per minute. If you just do the meals per hour, you say 1,000 meals over an hour is 1,000 meals an hour. So, there you go. Order reads, Kef saw 1,000 milligrams in 50 meals in 15 minutes. Drop factor 60. How many drops per minute? How many meals per hour? 50 meals is what we're infusing. Over 15 minutes is our time. Times 60 drops per meal gives you 200 drops per minute. 50 meals over a quarter of an hour, which is 0.25 hours. Do the math. It's 200 meals per hour. You'll note that with 60 drop tubing, and this is the only drop factor tubing that this happens with, but with 60 drop tubing, your drops per minute is also your meals per hour with 60 drop tubing. And if you sat down and looked at it, you would understand why, because there's 60 minutes in an hour and you got 60 drops per meal. But that's just, you don't have to go and figure all that out. Just remember that 20 drops per minute is 200 drops per minute is the same thing as 200 meals an hour if you're using 60 drop tubing. The MD orders 500 milligrams of Levaquin to be administered over 30 minutes. Available is Levaquin 500 500 milligrams in 100 mils. The drop factor is 15. How many drops per minute? How many mils per hour? So your volume to be infused is 100 milliliters. Your time to infuse it in is 30 minutes. Your drop factor is 15. So you do your 100 over 30 times 15 gives you 50 drops per minute. To do your meals per hours, you would say 100 mils over half an hour, which is 0.5 of an hour, and that gives you 200 mils an hour. An IV is regulated at 50 drops per minute. The administration set is a micro drip, which, remember, is 60 drops per mil. In 5 hours, the client will receive how many milliliters? Okay, so this one's different than what we've been doing, but you still just have to figure out how many meals an hour and then multiply it times 5 hours, right? So you just have to figure out if they're getting 50 drops a minute and there's 60 drops in a meal, how many meals are you giving him in a minute? And then just multiply by 60. So what we did was we said 60 drops is 1 meal. We know that. That's a known that we have on our tubing. 60 drops is 1 meal. But we're giving him 50 drops. So we need to know how much we're giving him, how many meals we're giving him that 50 drops. So that's our X. So 60 drops is to 1 meal as 50 drops is to X. You solve for that, and it comes out that X is 0.83333 meals in a minute, because we're giving him that many drops in a minute, 50 drops in a minute. So 50 drops is 0.8333 meals. So that's how much we're giving him in a minute. Multiply that by 60, and it gives you 49.99 drops in an hour, meals in an hour, which is 50 meals an hour, basically. Multiply that times 5 hours, then you've got 250 meals in 5 hours. A lot of steps to that. You really kind of just have to think it through. A lot of steps to it, but you take it one step at a time and you can get there. But you just have to think, I've got 60 drops in a meal, and I'm giving him 50 drops. So how many meals is that in a minute? And then you just have to multiply that times 60 to get per hour. Then you multiply that times 5 to get per 5 hours. You can do it. You just have to think about it. An IV is infusing at 22 drops per minute. The drop factor is 10 drops per meal. In 4 hours, he will have received how many meals? Once again, I know my known is I've got 10 drops in a meal. I'm giving him 22 drops in a minute. So how many meals am I giving him in a minute? If I can figure that out, then I can take that to how many in an hour and then how many in 4 hours. So I say there's 10 drops in one meal. So 22 drops is X meals. So I solve for my X. 10 drops in one meal, so 22 drops is in 2.2 meals. So my 2.2 meals that I'm giving him per minute, I just multiply that times 60, and that comes out to 132 meals an hour, times that 4 hours that the question's asking me. So I have 528 meals in 4 hours is what he's getting. I took my 10 drops per meal and said, well, I've got 10 drops per meal, but I'm giving him 22 drops every minute. So I figured out how much 22 drops was. That was 2.2 meals, so I'm giving him 2.2 meals a minute. Then I multiply that by 60 to get per hour, and then I multiply that by 4 to get per 4 hours. It's not hard, you just have to think about it. IV is infusing at 9 drops a minute. The drop factor is 10. In 24 hours, how much will he receive? Once again, if 10 drops is one meal, but I'm giving him 9 drops, that's X meals. That's what I want to know. How many meals am I giving him per minute? So I say 10 drops is to 1 meal, as 9 drops is to X meals. 10X is equal to 9. X is equal to 0.9 meals I'm giving him in a minute. If I'm giving him 9 drops a minute, I multiply that times 60, which comes out to 54 meals an hour times 24 hours. That comes out to 1,296 meals in 24 hours. IV is infusing at 80 drops per minute. The drop factor is 20. In 6 hours, the patient has received how many meals? He is getting 20 drops in one meal, according to his drop factor, but I'm giving him 80 drops per minute. So how many meals am I giving him per minute? I'd have to say 20 drops is one meal, as 80 drops is the X meals. Solve for my X and find out that I'm giving him 4 meals a minute. Multiply that times 60, 240 meals in an hour, times my 6 hours. That's 1,440 meals in 6 hours. Normal saline, 600 milliliters, is infusing at 25 drops a minute. The administration set delivers 20 drops per meal. How long will it take for this IV to go in? So we've got 600 mils going at 25 drops per minute, and the administration set is giving him 20 drops per mil. So what I have to figure out is how many meals an hour am I giving this person, and then just look at 600 mils, divide that by how many meals an hour I'm giving him to figure out how many hours it's going to take. So I say 20 drops is to 1 meal, as 25 drops is to X meal, because I'm giving him 25 drops a minute, so I want to know how many meals I'm giving him. So 20 drops is to 1 meal, as 25 drops is to X meals. Then you solve that out to say 1.25 meals per minute is what I'm giving him with my 25 drops. 1.25 meals per minute times 60 is 75 meals in an hour I'm giving him. So I say if 75 meals takes 1 hour, because I'm giving him 75 meals an hour, then how many hours will it take to put 600 meals in there? And you see, you solve that out, solve for X on that to come out with 8 hours. 75 meals is to 1 hour, as 600 meals is to how many hours? Then you multiply your means and your extremes, and solve for X, and it comes out to 8 hours. There's probably other ways to do that, but with ratio and proportion, that's what we're doing. Patient is to receive 500 mils of lactated ringers at 80 mils an hour. If the infusion was started at 8 a.m., what time would it be completed? So we've got 500 mils going at 80 mils an hour. What we need to figure out is how many hours is that going to take to go in, and then we need to look and see what time will that be, beyond 8 o'clock. So 80 mils is going in for 1 hour, but I've got 500 mils to put in, so how many hours is that going to take? 80 mils is to 1 hour as 500 mils is to X. Solve for X, that comes out to 6.25 of an hour. That 0.25 of an hour, if you say 0.25 times 60, is 15 minutes. So 6 hours and 15 minutes. 8 o'clock in the morning plus 6 hours and 15 minutes comes out to 2:15 in the afternoon. Excuse me. Okay, I'm getting tired of talking. Y'all are getting tired of listening, I'm sure. Okay, so you just have to be careful about converting that 6.25 of an hour to 6 hours and 15 minutes. That's not 6 hours and 25 minutes. That's 6 hours and 15 minutes. You just have to be careful about that. Doctor orders 2.5 liters of normal saline to be infused at 200 mils an hour. The total infusion time will be how long? 2.5 liters is 2,500 mils. 200 mils an hour is what we're doing. So 200 mils going in at 1 hour is the same thing as 2,500 mils going in X hours, because we need to see how many hours it's going to take. So 200 is to 1 hour as 2,500 is to X hours. Solve for X, and that comes out to 12.5 hours. Once again, 0.5 of an hour, 0.5 times 60 is 30, so it's 30 minutes. So it's 12 hours and 30 minutes it's going to take for that IV fluid to go in. You're caring for a patient that is receiving normal saline, 250 mils an hour. How many bags? And a bag is a 1 liter bag, like I showed you in class today. That one wasn't full today, but a bag is usually 1 liter of IV fluids will be needed for 24 hours. So 250 mils is to 1 hour as X mils is to 24 hours. So when you solve for X, it comes out to we need 6,000 mils for this person for 24 hours. Which is, if you look at each bag is 1,000 mils or 1 liter, then that's 6 liters we need. So you have to be careful about, we don't need 6,000 bags. What it's asking is how many bags do we need? We need 6 bags. We need 6,000 milliliters, but we need 6 bags. You're caring for a client who's receiving D5W at 110 mils an hour. How many bags? Once again, 1 liter bags will you need for 24 hours. 110 mils going in 1 hour is the same thing as X mils going in 24 hours. Solve for X, that comes out 2,640 mils is what we need in 24 hours. Well, pharmacy can't send a bag that's 2.6 of a bag, so pharmacy's going to send 3 bags. So once again, you'll just have to decide what your instructor's asking there. But if you're asking how many bags does pharmacy need to send for 24 hours, it's 3 bags, because you're not going to use, you can't, well, I guess you could use it, take it down, but if you're talking about how many pharmacy needs to send, they're going to send 3. You're caring for a patient who's receiving fluids at 75 mils an hour. The bag reads 500 milligrams of Levaquin and 250 mils of normal saline. How many milligrams per hour are they receiving? So if you look at, and this looks like I've tried to plug it into that desired dose over available dose is equal to, times the quantity is equal to your quantity. I don't like flipping these formulas around, but you technically can. You can say your desired dose is X. We don't know how many milligrams they're getting. Over your available dose, which is 500, times the quantity, which is 250, comes out to 75 mils an hour. So you could just kind of backtrack it that way and solve for X, and you come out to 150 milligrams as your desired dose. That's the dose that they're actually getting. I prefer the ratio and proportion on these kind, though. 500 milligrams and 250 is the same as X milligrams and 75. He's getting 75 mils an hour. So this 500 milligrams in 250 mils is going to be the same thing as X milligrams in our 75 mils we're giving him per hour. If you solve for that, it comes out to in 75 mils, there's 150 milligrams of medicine. So you could say, you can make that 500 and 250, you can make that 2 milligrams in 1 mil. So you could say 2 milligrams is to 1 mil, as X milligrams is a 75 mils. That makes it pretty easy because you can just look at that and tell that that's 150 because 2 times 75 is 150. Anyway, so you just have to solve for this 75 milliliters. How much is he getting medicine-wise in this 75 milliliters? And then if you know how much medicine he's getting in 75 milliliters, then you know how much medicine he's getting per hour. If you know how many milligrams is in 75 milliliters, you know how many milligrams he's getting per hour because he's getting 75 milliliters per hour. Anyway, there's other ways to solve that, but that's one way to do it. You're caring for a patient who's admitted for an MI. He's receiving heparin at 17 mils an hour. The bag reads 25,000 units in 500 mils. How many units an hour is he getting? And these are some problems that you'll see a lot because you see these in the hospital. The desired dose is what we want to know. What we want is what dose is he getting. So the ordered dose that he's getting is X in this situation. The available dosage is 25,000 units in 500 mils. And to get that X, it's taken 17 mils an hour to do it. So if you solve for X, that comes out 850 units is technically what he's getting. Once again, I don't like having to flip-flop that formula around like that. I prefer to do ratio and proportion in these situations where if 1 mil is 50 units, which is what this bag is 25,000 units in 500 milliliters. I just divided my 500 into my 25,000 to come up with 50 units per mil. The concentration is 50 units per mil. You can see that. So 1 mil is 50 units. So 17 mils is X units. So you solve for that, and 17 mils, this 17 mils an hour that we're giving him is 850 units. Because 1 mil is 50 units, but we're giving him 17. So that 17 mils that we're giving him in an hour is 850 units that we're giving him in an hour. You really can solve everything with ratio and proportion, as much as I don't know that I really like it. You can do it. Physician orders 750 milligrams an hour of a medication. The bag reads 2 grams of medication in 1 liter of lactated ringers. This is 2 milligrams per mil, and you guys are smart, you knew that already, because this is 2,000 milligrams in 1,000 milliliters, right? So this is 2 milligrams per mil. The drop factor is 20 drops per mil. How many milliliters per hour how many mils per hour should you administer per hour? That's redundant. How many drops per minute? Okay. So the formula is our desired dose is 750 milligrams. Our available on hand dose is 2 milligrams in 1 mil. So you solve for that, and that tells you that our desired volume, the quantity of our desired dose is 375 mils per hour, or 375 mils. What he's ordered is 750 milligrams. What we need to know is how many mils contain 750 milligrams. And that's what this formula is. That's that desired dose, 750 milligrams, over available dose, which is 2 milligrams, times the quantity of available dose, which is 1 mil. And that gives us our 375 mils is what 750 milligrams is in. So if we're going to give him that per hour, we're going to give him 375 mils per hour. To solve it, to solve it in drops per minute, 375 mils is what we're giving him over 60 minutes times our drop factor, which is drops per mil, 20 drops per mil. So that comes out to 125 drops per mil to solve it in drops per minute. Because if we know how many mils we're giving him per hour, then we can take it to how many drops we're giving him per minute. 375 mils over 60 minutes times our drop factor is 125 drops per minute. Once again, there's probably other ways to solve that, but that's using the formulas. right there. Ratio and proportion, 2 milligrams is to 1 mil, and 750 milligrams is to X mils. Once again, what we're trying to figure out is 750 milligrams is what we're giving him per hour. How many milliliters is that? So 2 milligrams is to 1 mil, as 750 milligrams is to X mils. You solve that out to say that 375 mils is how much we give him per hour to give him that 750 milligrams. So it's not hard, you just have to think through it. To do your drip rates, you simply take what you get per minute and divide it by 4, and then you count it for 15 seconds. And I think I've talked through that enough where I really don't have to go through that again. But if you've got 45 drops per minute, then in 15 seconds, that's basically going to be 11 drops. It's not as exact a science as a pump, so that's why things that have very exactly have to be dosed have to be on a pump. But if you have 100 drops per minute, you're going to count for 25 drops in 15 seconds. If you have 75 drops per minute, you're going to try to get 19 drops in 15 seconds. If you are going for 10 drops a minute, you go 3 drops in 15 seconds. And once again, it's not a very exact science. As the volume changes in the bag and gravity pull changes, it goes slower sometimes. So once again, it's not the most exact science in the world, but it's better than not knowing how to do anything at all about it. All right, see you tomorrow.